from there the user can use it. Important aspects in WSN is the sensor design and network design. Sensor design involves what type of sensor we use, which will give required data, what will be accessories, which will complete sensor node, which will transmit the data generated to base station and how much power consumption will be there and how this power will be provided to sensor node. In network design, we configure the sensor nodes and see how the generated by sensor is effectively transmitted to the server or control center. The network design, we see that where will be the base station, whether there is need of relay nodes. The relay nodes are needed if sensor nodes are not able to effectively transmit data to base station due to long distance. What size of data will be transmitted, and accordingly the transmitter and receiver would be. How the sensor placement will be done to gather the desired data, what type of communication medium will be there, short range or long range, and how the power consumption will be minimized and the power will be provided to the system. Whether it will be a self-generative or external power. These are the design aspects. Data from sensors is produced generally in two ways, whether it is a time series or continuous data or a sequence of reading where data is generated ad hoc. WSN are of two types: fixed network. Sensors are fixed at fixed locations such as bridges, tunnels, etc. Movable network, sensors attached to the locomotive track machines and coaches, etc. The data from movable network is logged with accompanying GPS coordinates. Movable sensors can monitor the whole track length, but only the sections of the train where sensor nodes are attached, whereas fixed sensors can measure the whole train, but only at a specific location where the nodes are mounted on track. A case study, we have tried this on one of our Tamping Express 3954, working in an hour division from Kanpur to Tumla. Main objective of this was data acquisition, monitoring and reporting of core parameters in real time, tamping performance and machine health statistics, GPM and credibility to the tamping performance data, which when transmitted our GSM network enables real-time monitoring and control of the various activities being performed in the field. This is the system overview where data are taken from the tamping machine as well as the location data from the GPS, and onboard equipment is installed in the tamping machine, which we call as TMRU, Tamping Monitoring Remote Monitoring Unit, and from there it is the data collected goes to the server, and from there it is for use for web application or as well as for even mobile application. This is a view where this system has been installed on the Tamping Express. The main features is all recorded data is stored in TMRU, that is tamping monitoring remote monitoring unit, tamping machine. In case GSM network fails or unavailable, data is retransmitted whenever it is restored. Data are stored over cloud so that it is available through internet to all the authorized users. Facility for recording data and viewing in graphical and chart mode. Remotely analyzed with the help of auto-generated graphs and tabular charts. It can be viewed on GVI, General Visual Interface. Can also be filtered for viewing and analyzing. Also equipped with mobile app to enter various data by operators. These are the data capturing pre and post tamping data. Main important is general left super elevation, that is the input data, target were sign, tamping unit depth, were signs, vibration pressure, vibration pattern left and right, whereas output pre-tamping cross level, were sign, lift, then post-tamping cross level, slew values. Other is for machine health point of view, system pressure 1 and 2, counter pressure, ZF gear pressure, high pressure or pneumatic pressure, whether it's from track point of view, the number of insertion recorded is squeezing time, squeezing pressure, and the working speed of this. The basic data of machine is filled, the track machine numbers, operator name, block section, dates. Data can be filled even offline when machine is standing, and even it can be fed into the system through mobile. by the authorized operator. These are the onboard equipment which is installed in the machine. These are the technical details and the desired requirement. I just go through this. This is the system. We can see the machine position through internet, and this machine where it is working, the red mark showing that the machine is standing. Another is the yellow mark. The machine is moving from one block section to the other. Is transit mode, and another is when it is shown in the green. It means machine is actually tamping between the block section during a block time. Track real-time or static view, input track parameters, machine parameters, data sheet generation and report in action format, daily, weekly and monthly reports can be generated. Reports can also be generated for any particular date or block, and performance can be analyzed, highlighting of irregularities. Until recently, railway inspection has been visually performed, but this only examines objects superficially and intimately, as told by all other authors also. WSN wireless sensor network are objective and can provide data from entire object, including internally, to allow the whole object health to be fully assessed and to analyze durability and remaining lifetime. Further, we are planning to do failure analysis, troubleshooting, preventive maintenance can also be incorporated in the system, and location of actual defect in track with respect to OHE mass is to be incorporated. We are working on that. Thank you, sir.
Thank you, Mr. R.K. Gwal. The paper presents a great promise, and in many areas the concepts can be used, be it track, bridge, or even a track machine or rolling stock. So this is the way in which we should need to go in future. Now I invite Mr. Kevin Fry. He is from Derby, UK. The value of greater infrastructure, condition, monitoring and development trends. That is the title of his presentation.
Good afternoon, ladies and gentlemen. Small correction, I'm standing in for Kevin Fry. I'm Prabhu Shankar, Director for Alpha BT in India. I've seen the previous presentations more talking about the importance of the good asset management in rail industry. I'm here to share a few slides about our success story within the network rail in the UK. About us, Alpha BT is a Fortune 500 company based in London, listed in London Stock Exchange, with an annual revenue of close to 8 billion this year. We have more than 35,000 employees in around 80 countries, primarily focused on UK and US market, and we have businesses in Canada, Middle East and Southeast Asia as well. We operate across the life cycle of infrastructure assets. We cover the entire spectrum from rail to road, bridges to highways, you name it, we will be there everywhere in the infrastructure industry. So the prime focus for today is the Alpha BT Rail. Alpha BT Rail is one of the business unit within the bigger Alpha BT group. It has the electrification division, track, power, signaling, civils, and specialist rail plant, as well as the more important, the technology solutions which we are here talking about. So ETS is a unit within Alpha BT Rail that has the specialist research and development engineers, close to 300 of them, developing this sort of asset management technologies for the rail industry in total. So the business case for the better asset management comes from our experience in the European market. You can see this graph. The average asset management cost per track kilometer in the Europe, it's closely costing about 74,000 euros per kilometer. So this is the graph showing the different railways within Europe, how much they are spending on asset management. With this, you can appreciate a hell lot of money is going on asset management. But if we implement the better asset management, the modern technologies, which is about 3% of the cost in what we are spending on the maintenance. It could improve or save considerable money, close to 10 to 20%, which will give you a greater return on investments. So WSN asset management solutions are proven. It's on innovative solutions that has been implemented from the experience WSN had in maintaining 150 years old railway in UK. So the application includes track, overhead line, conductor rail, switches and signaling systems. So True Track is one of such product that has been very innovative, and this measurement system has been can be fitted. It is very compact. It can be fitted in a passenger train, and by fitting into a passenger train, we are enabling more frequent inspections, and more frequent data will provide you a better understanding of your assets upfront. So in early stage, you can understand so that you can avoid failures, and it is also possible to add more value to whatever you are doing on asset management. So this system has been mandated in all new fleets in the UK by the Department of Transport, and this technology has also been adopted by Hitachi, Bombardier and Tokyo Rail corporations. And we have asset management solutions that is being implemented, it's already implemented in the UK market. Visual inspection track. This is another one technology that has been implemented in the UK. So 5 vehicles has been fitted in the network rail. That collected data is being centrally analyzed, and the predictions are being made on other asset conditions or any missing information on the assets that you operate. Basically, this has enabled network rail to take away around 700 track inspectors from the actual rail inspections. Now we have only 35 of them, just comparing the data and assessing the effectiveness of the inspection records. So this also enables a couple of reporting options that can be given by the software, which is a data map that is primarily for visualization and decision support. So this is location-centered database. It's a holistic view of all measurements, and it improves the understanding of the conditions upfront. And this is fully implemented in London Underground and in Australia as well. And we also currently being supplied for Hong Kong Railway as well. The other product we have is our Omni Surveyor 3D. So this is a video surveying equipment that can be fitted into a locomotive. This is extensively again used in the network rail. So it brings the rail network into your office. You can plan for your expansion or maintenance. You can check your signal sighting, or you can use it for any purpose that you can think of. This gives you as good as a live environment of your railway network upfront in your office. By sitting in your office, you can measure, you can put machineries and see how this is going to impact your planning activities. So in summary, we have more advanced technology that's currently being implemented in the network rail, and with this network rail is currently getting benefited in a big way. We are sure and we are very keen to implement these technologies in the coming years with Indian Railways as well. Thank you.
Thank you, Mr. Prabhu. Shankar. Very good paper on remote condition monitoring and other areas of rail and other infrastructure. And we look forward to more such partnership with other stakeholders in adopting the same in Indian Railways. Now the last paper is by Mr. KLVS Vishwanandam on leveraging development in monitoring technology for optimizing track maintenance.
Esteemed superiors and my dear colleagues, I call this topic, rather than leveraging developments, I call this as technological developments through modern gadgets. And this will be a helping hand for the track maintenance, how they will be helping in the track maintenance. Any asset's life or the security or the safety is totally depending on the inputs given to that particular asset. How the inputs will be given? Purely based on the inspections we carry out. The inspections basically will be treated in the two segments. One is man dependent and the second is technology dependent. So far our engineers have given various types of technology dependent inspections and the technology dependent inputs when the track is totally in the stable condition. But the second kind of inspections what we could not able to dispense of so far